Because of our work in London on the water supply system, we have for a long time engaged with the London Fire Brigade about the ability to fight fires. And over the years, we've become aware about the protocols that they use to fight fires and how they set themselves up to fight fires. We also became fully cognizant of the UK fire codes for buildings and what fire flows were needed for different types of buildings and how to calculate those needs using building height, size and usage. Finally, for many years, Stantec had built computer network models of the water supply system in London. And these models can be used to tell us how much water is available from every fire hydrant. The computer models that we built for Stantec Fire Flow are also unique in that they represent not only the water supply system and its fire hydrants, but also the hoses which are laid between the hydrants and between the fire hydrants and the fire engine appliance, as demonstrated in this graphic, with these strange little dummy nodes and pipes here representing the fire hydrant, and then the hoses which are laid up to the fire engine itself. And we are able, as I will show you in a later slide, to calculate the length of the hoses and then recalculate the length of the hoses, which will affect the fire flow, and then recalculate the fire flow in real time, so that the fire brigade know exactly how much they're going to get, water they're going to get. With this information, we're able to build an online system which models every building in London, all 1.7 million of them, and creates a 3D digital twin for every building. Every building is modeled, and that means for individual sites with multiple buildings, each individual building on the site is modelled. And you can see on this slide our representation, our digital 3D representation of the Houses of Parliament and Buckingham Palace. So what does our system do? It analyses every building to calculate the fire flow required to fight fires at each building, and then to calculate how much water is available from every fire hydrant. And it identifies the best hydrants to use for each building. This slide shows the hydrants which have been identified for this particular fire. The hydrants marked yes are hydrants where we can lay a hose directly between the hydrant and the building and there is no obstruction. And the hydrants marked no are either they're obstructed, a hose can't be laid, or they're too far away. This fire flow system is already being used to check planning applications for proposed developments. Their fire flow requirements can be calculated and the available fire flow checked to see if it is compliant. Planning applications have been rejected or changed as a result of this analysis. Also, when a major convention centre was changed to a COVID hospital, the fire flow system was used to evaluate whether there was sufficient fire flow for this change of use. For very large buildings, fires are often localised, and the point at which to attack the fire flow determines which hydrants should be used. Fire flow system gives the fire services the best hydrants to use at any point of attack, and it will also generate the hose routes and lengths for them to use, and they can recalculate the available fire flow on that basis. Also, if there's an obvious shortfall in fire flow, tankers can be ordered and the water company engaged to try and increase the fire flow. All of this saves valuable time that can be spent fighting the fire rather than looking for water, and mitigation measures can already be in place before they arrive at the event. A prototype of the fire flow system was built by Stantec using internal research and development funding and was demonstrated to Thames Water in late 2019. And the system was procured and delivered in 2020. Thames Water and London Fire Brigade, the two key stakeholders, were engaged during the system build process, and a number of further revisions were built into the system. And the final system was rolled out for everyday use in November 2020. And so what are the outcomes of this work? Stantec Fire Flow is now in daily use by the London Fire Brigade. The fire hydrants can be checked en route to any event to determine which are the best fire hydrants to use, to connect to, where hoses can be laid, length of hoses needed, and how much water will be available to fight the fire. For Thames Water, the system has identified the most at-risk buildings in London, and mitigation measures are already now being put in place. Fireflow will drive investment where it is needed to remove those buildings from the high-risk list. Stantec Fire Flow is a 24/7 online system available to the emergency services, which can be accessed by multiple different devices, either in the office or en route to a fire. The system is updatable and maintainable, and the highest risk buildings have been identified and mitigation measures started. We can see that every day London Fire Brigade access this system, and during major events, fires, we can see that the system is always accessed and by multiple users to obtain the information they need to fight the fire. Stantec Fire Flow has won the UK Water Industry Health and Safety Award in 2021 and is a finalist in 3 other awards, UK national and global awards. And what of the future? The system has a generic core. It can be replicated in any state or country in the world. The UK fire codes can be replaced and the rules about fighting fires can be updated, and the local fire service rules inputted. Using satellite data, digital twins of every building can be created. The system can hold data related to the building, including location of fire escapes, firefighting infrastructure such as sprinkler systems and hose reels. Fire risk assessments can be stored in the digital twin and be accessed en route to an event. Finally, our plan is to link directly into SCADA so that the fire flow system can be updated on a regular basis, maybe every 15 minutes, so that real-time data is available to users. There are also plans to use the system to support the water companies or water suppliers operationally, as water pressures can be visualized in 3D and buildings at risk of loss of supply due to low water pressures can be identified.